Have you ever wondered why one ordinary yam has fascinated scientists, historians, and millions of people for generations? Not because it tastes different, not because it looks different, but because of a mystery that has followed it for decades. Some people believe this humble yam may be connected to one of nature's greatest surprises, the birth of twins. In parts of Nigeria, especially in communities famous for unusually high numbers of twins, this belief has been passed down from one generation to the next. But is there really something hidden inside this ordinary-looking yam? If so, what are scientists and manufacturers interested in? And why would modern factories spend millions of dollars processing it using some of the world's most advanced technology? Today, we're stepping inside a massive high-tech processing facility to follow the complete journey of this remarkable crop. From freshly harvested yams arriving by truck to highly refined plant-derived ingredients used in industries around the world. And near the end of this documentary, we'll reveal the naturally occurring compound inside certain yam species that has attracted scientific and industrial attention, and explain what researchers actually know about its connection to the long-standing twin tradition. The answer might surprise you. So stay with us until the very end, because the final reveal is where everything comes together. If you enjoy discovering how ordinary plants become extraordinary industrial materials, don't forget to subscribe. Now, let's step inside the factory. The journey begins long before the factory doors open. Across fertile farmland, farmers carefully harvest mature yams from the rich soil. Unlike many crops that can be collected by machines, yams require patience. Each tuber grows underground. Workers gently loosen the soil to avoid damaging the thick, starchy roots hidden beneath the surface. One by one, the yams emerge. Some are as small as a loaf of bread. Others are almost as long as a person's arm. Every harvest tells the same story. Months of growth, careful cultivation, and the hope of producing high-quality crops. Once harvested, the yams are placed into large collection baskets before being loaded onto transport trucks. Thousands of kilograms leave farms every single day. Their destination? One of the most advanced processing facilities in the region. As the trucks roll through highways and country roads, few people realize that these ordinary-looking roots are about to begin an incredible transformation. To most people, they're simply food. But inside modern industry, there's something much more. The factory slowly comes into view. Massive stainless steel buildings, automated loading bays, long conveyor systems stretching deep inside the facility. Everything has been designed for one purpose: efficiency. As each truck arrives, workers don't immediately begin processing. Every shipment is carefully examined. Technicians look for damaged yams, signs of spoilage, excess dirt, size consistency. Quality matters from the very beginning, because every step that follows depends on starting with the best possible raw material. Large robotic arms help unload thousands of kilograms onto moving conveyor belts. The belts move slowly, almost silently, carrying the freshly harvested yams into the heart of the factory. It's a strangely satisfying sight. Hundreds, then thousands, of identical roots moving together with perfect rhythm. This is where agriculture meets engineering. The first stop is cleaning. Although the yams have already been brushed on the farm, tiny amounts of soil still cling to their rough outer skin. Industrial washing systems begin removing every trace. Powerful streams of clean water spray continuously from every direction. Large rotating drums slowly turn as the yams gently tumble over one another. The motion is smooth, relaxing, almost hypnotic. Water flows, drums rotate, conveyor belts move steadily forward. Every stage is carefully synchronized. The goal isn't simply to make the yams look clean, it's to prepare them for precision processing. Even small particles of dirt could affect later stages. That's why the cleaning process is repeated several times. Each cycle removes a little more. By the time the yams leave the washing area, they look completely different. Their natural color becomes more visible. Their surfaces appear fresh, ready for the next step. Now the factory begins sorting. This is where technology quietly takes over. High-speed cameras scan every single yam. Laser sensors measure length and diameter. Automated systems identify imperfections. Within seconds, intelligent machinery decides where each yam should go. Smaller ones move in one direction, larger ones in another. Any damaged pieces are separated for other industrial uses. Watching thousands of yams move across dozens of conveyor belts is surprisingly satisfying. Everything happens without confusion, without delays, without wasted movement. Each yam seems to know exactly where it's going. Behind the scenes, sophisticated software coordinates the entire process. Every conveyor, every gate, every robotic arm, working together like a perfectly rehearsed orchestra. This level of precision allows the factory to process enormous quantities every day while maintaining remarkable consistency. Once sorting is complete, the yams continue toward one of the most visually satisfying parts of the entire facility: peeling. Massive automated peeling machines carefully remove the thick outer skin. Unlike peeling vegetables at home, these industrial systems are designed to remove only what is necessary. The goal is simple: preserve as much usable material as possible while eliminating the rough outer layer. Rotating rollers gently guide each yam through precision cutting systems. Thin ribbons of peel spiral away. Clean white flesh begins to appear underneath. The contrast is striking. Dark, earthy skin entering one side, bright, clean yam emerging from the other. It's another reminder of how engineering can transform an ordinary farming product into something ready for advanced processing. The peeled yams move onward without ever stopping. The factory never sleeps. Neither do the conveyors. Every few seconds, another perfectly peeled yam joins the line. Then another, and another. Quick question. Before today, did you know this much technology could be involved in processing something as ordinary as a yam? Let us know in the comments. And if you're enjoying this journey inside the mega factory, take a second to like this video and subscribe.
Send them to the
We
water.
have many more incredible industrial stories waiting for you.
Everything looks good.
Now, the real transformation is about to begin, because everything you've seen so far has only been preparation. And with every step, we'll move closer to discovering the naturally occurring plant compound that has made certain yam species the subject of scientific research and long-standing cultural stories about twins. The answer is still ahead. The peeled yams never stop moving. As they leave the peeling section, automated conveyor belts carry them toward one of the busiest areas of the factory. Here, speed and precision become everything. Powerful slicing machines wait ahead. Each yam is carefully aligned before entering rows of razor-sharp, rotating blades. Within seconds, thick tubers become hundreds of perfectly even slices. Every slice is nearly identical in thickness. That isn't just for appearance. Uniform slices dry at the same rate, making every stage that follows more efficient and more consistent. Thousands of slices flow across wide stainless steel conveyors like a moving river. It's fast, it's organized, and strangely satisfying to watch. The next destination is the drying hall. This room is enormous. Long tunnels stretch across the factory floor. Warm, carefully controlled air circulates continuously, while sensors monitor temperature and humidity every second. Nothing is left to guesswork. Removing moisture is one of the most important steps in the entire process. Too much moisture encourages spoilage. Too little can damage the quality of the plant material. Engineers have spent years designing systems that remove just the right amount. As the slices travel slowly through the drying tunnels, they gradually become lighter, firmer, and easier to preserve. Hours later, they emerge looking completely different from the freshly peeled yams that entered the factory. The transformation is remarkable. Now the dried slices enter another massive production hall. This is where the factory begins unlocking what has been hidden inside the yam all along. Towering industrial mills slowly come to life. The dried slices disappear into enclosed grinding systems. Moments later, they emerge as a soft, pale cream-colored powder. The texture is incredibly fine, almost like flour. The powder moves into a sealed extraction area. Unlike the noisy milling room, this section feels calm. Large stainless steel vessels stand several stories high. Pipes connect one processing chamber to another. Digital control screens monitor every stage. Technicians watch from enclosed control rooms as automated systems do most of the work. Inside these vessels, carefully controlled extraction processes begin separating groups of naturally occurring compounds from the yam powder. This isn't about creating medicine. It's about separating and concentrating naturally occurring plant materials so scientists and manufacturers can study or use them in different industrial applications. Time, temperature, flow rate. Every detail matters. Small changes can affect the purity of the final extract. That's why computers constantly adjust the process. Nothing is rushed. Nothing is left to chance. As extraction continues, the liquid moves through a series of filtration systems. Each filter removes particles that are no longer needed. With every stage, the extract becomes cleaner, more refined, more concentrated. Watching the liquid move through transparent industrial pipes is almost hypnotic. Golden lights reflect from polished stainless steel. Pumps operate with perfect rhythm. Valves open and close automatically. Every movement has been carefully programmed. This is modern manufacturing at its best. Quiet, precise, efficient. The refined extract now enters one of the most secure areas of the facility, the laboratory. Here, scientists don't guess, they measure. Small samples are collected from every production batch. Advanced analytical instruments examine the material in extraordinary detail. They check purity, consistency, composition. Every result is recorded. Every sample is compared against strict quality standards. If something doesn't meet the required specification, it doesn't move forward. This level of quality control is one reason modern plant processing facilities can supply manufacturers around the world with reliable ingredients. Whether those ingredients are used in research, food production, cosmetics, or pharmaceutical manufacturing, consistency is everything. Here's something interesting. People often imagine factories as places filled only with giant machines. But in facilities like this, some of the most important work happens inside laboratories. Scientists and engineers work together. The factory produces the material. The laboratory confirms exactly what has been produced. Without that partnership, large-scale manufacturing simply wouldn't work. If you're still watching, you've already seen this ordinary yam transformed into clean slices, fine powder, and highly refined plant extracts. But one important question still hasn't been answered. What exactly are scientists looking for inside these yams? And why has one naturally occurring compound attracted so much attention over the years? Don't worry, we're almost there. The answer comes in the final stage of this documentary, and once you understand it, you'll also understand why stories connecting certain yams with twins have survived for generations, even though modern science urges caution before drawing conclusions. If you've made it this far, type YAM in the comments so we know you're watching until the reveal. And if you're enjoying these behind-the-scenes factory journeys, don't forget to subscribe. In the final part, we'll reveal the plant compound that has made certain yam species famous, explain how it has historically been used in industry, and separate long-standing cultural beliefs from what scientific research has and hasn't been able to confirm. The most surprising part of this story is still ahead. We followed this ordinary yam from the farm, through washing, sorting, peeling, drying, grinding, extraction, filtration, and laboratory testing. Now comes the question we've been asking since the beginning. What exactly are scientists and manufacturers looking for inside these yams? The answer begins with a naturally occurring plant compound found in some species of yam. It's called diosgenin. Although it exists naturally inside the plant, it isn't present in large amounts, which is why careful extraction and purification are so important in industrial settings. For many decades, diosgenin attracted the attention of researchers because it could serve as one of the starting materials used in the manufacture of certain steroid hormones after extensive laboratory and industrial processing. That discovery made some yam species valuable far beyond the dinner table. But here's where the story becomes even more interesting. Long before modern laboratories existed, long before stainless steel extraction tanks, long before computerized factories, communities in parts of Nigeria had already noticed something unusual. Some towns became famous for having an exceptionally high number of twins. One of the best-known examples is the town of Igbo Ora. For generations, many families believed that the local diet, including frequent consumption of certain yam varieties, might be one reason so many twins were born there. That belief became part of local culture. Stories were shared. Traditions were passed from parents to children. Visitors came from around the world to learn about the remarkable number of twins in the community. As scientists became interested in the phenomenon, they began asking the same question many people still ask today. Could diet play a role? Researchers explored that possibility alongside several others. They examined genetics. They studied environmental influences. They investigated local eating habits. Including the regular consumption of yam, some researchers proposed that naturally occurring compounds found in certain foods deserved further study. Others pointed out that genetics and other factors might also contribute. To this day, no single explanation has been scientifically confirmed as the sole reason for the unusually high twinning rate. That's why this mystery continues to fascinate both researchers and the public. The factory you've seen today isn't producing twins, and it isn't proving the traditional belief right or wrong. Instead, it demonstrates something equally remarkable: how an ordinary agricultural crop can contain naturally occurring compounds valuable enough to attract the attention of scientists, engineers, and manufacturers around the world. What begins as a simple yam harvested from the soil can become a carefully refined, plant-derived ingredient for research and industrial applications after extensive processing. That journey alone is extraordinary. It reminds us that many everyday plants contain complex natural chemistry hidden beneath their rough outer skin. Chemistry that modern science continues to study. Chemistry that industry continues to refine. And chemistry that still leaves room for new discoveries. Perhaps that's why this story has endured for generations. It sits at the meeting point of culture, agriculture, science, and modern engineering. Whether future research uncovers more about the remarkable twinning rates in places like Igbo Ora remains to be seen. But one thing is already clear. Behind every ordinary yam lies an extraordinary journey. From rich farmland to one of the world's most sophisticated processing facilities, to laboratories where scientists continue exploring the incredible chemistry found in nature. Sometimes, the greatest discoveries don't begin in a laboratory. They begin in a field, hidden beneath the soil, waiting for someone curious enough to ask a simple question. What makes this plant so special? If you enjoyed this journey inside the mega factory, don't forget to like this video, subscribe, and turn on notifications. Every week, we explore incredible factory processes, hidden manufacturing secrets, and the surprising science behind the products and materials that shape our world. And if there's another fascinating factory process you'd like us to explore, leave it in the comments below. Your suggestion could become our next documentary. This documentary is presented for educational and documentary storytelling purposes. It explores a long-standing cultural belief together with current scientific understanding. While some yam species naturally contain compounds, such as diosgenin, that have important industrial and research applications, there is currently no scientific consensus that eating yam causes or increases the likelihood of conceiving twins. The discussion of twinning reflects ongoing scientific interest and cultural history rather than a proven medical conclusion. Thank you for watching, and we'll see you in the next factory journey.